that we provide, and hopefully you have been joining us in the past for some of our webinars. If not, welcome to the Filtrexx webinar series, and we hope you'll join us for some of the webinars in the future as well. We generally provide these once a month or so. Also, I think Ann mentioned this already, but we should have ample time for questions at the end of the webinar, so please hold your questions until then, or at least we'll do the Q&A at the end. If for some reason we don't have time or go over the allotted time, the last slide will have my contact information, so feel free to call me or email me after the webinar or at your convenience if you have a question we didn't get to, or if you have something specifically you'd like to discuss offline related to a project or something you're working on that may not be suitable for the entire group here as well. So with that, we will go ahead and get started. I always like to start out with a little bit of an outline of how we'll move through the next 45 minutes to an hour here. But part of what you'll notice in this presentation is the link between green infrastructure and green building, and specifically as it relates to what Filtrexx does and compost-based BMP. So they're terms that are often used separately, but there is a lot of overlap, and obviously they're often used in conjunction as well on specific projects and sites. I'm going to talk about compost and the compost-based BMPs. Really, if you're somewhat new to this, you'll gain a lot out of how we're using compost, why we're using compost, and really how it works in a lot of these applications. I'll share with you some of the more notable research on the performance of these BMPs and really how that's being transformed into design criteria and design tools. It's one thing to have scientific research, but it's really important to us to follow that through to the design and engineering and application of that research. So from there, I'm going to get into how these various compost BMPs fit into each of the potential LEED credit categories and how they can be applied for maximum credit accrual using these applications. And then I'll wrap up with a LEED Platinum case study. So starting off with a little bit of kind of stormwater basics here, 101. According to a recent report, about 850 U.S. cities or municipalities had either outdated or under-designed stormwater management infrastructure. That's not the only reason, but in large part because of this, fully 3/4 of all Americans live near a polluted water body, according to the U.S. EPA. And another study has said that if we were to add up in aggregate the aggregate of what we pay as a society every year to clean up our water bodies due to ineffective stormwater management, we're paying about $44 billion per year. And something that is getting more and more talked about, but in some discussions I think historically has been left out, is that water treatment can be energy intensive and therefore also carbon intensive in most instances. So we're going to talk a little bit about this as well. So what is green infrastructure? If you've seen one of my webinars or presentations in the past, I can almost guarantee that you've probably seen this slide before. It's one of my favorite slides, and I think it does an excellent job of pictorially describing what happens to hydrology and stormwater as we move away from natural systems and as we change our land use patterns into more urban settings. So if you look at really the color coordination here, you see what happens as we move away from vegetation, biomass, root structures, organic matter, both above ground and below ground, really relying on natural systems for the most part. What happens is, generally speaking, as we change that land use pattern, we trade that for more and more impervious surface, as you see in the urban or ultra-urban type environment to your right. And if you follow the color coordination, you see that the natural systems to the left do a very effective, and I would add a very free job of managing site hydrology, or really managing our stormwater to the effect that there is none or very little. And obviously, if there is none or very little, you don't require much infrastructure or gray infrastructure to handle that stormwater. As we get rid of that, we have more and more impervious surface. Less is infiltrated, less gets naturally filtered through interflow or subsurface flow, which then recharges groundwaters as well as surface waters, depending on whether it's just below the surface or goes down deeper. And you can see what happens is we trade that for more and more surface runoff. And there's plenty of studies now that show the greater the impervious surface in a watershed, the greater the surface runoff, which you see here in red. And we also know that the greater the surface runoff volume or stormwater volume, the higher the pollutant loads. There's a direct correlation between pollutant load and runoff volume or stormwater volume. And of course, the higher the pollutant loads, the more polluted the water bodies will be in that watershed, or more impaired. So we can make that long story short and basically say the more impervious surface in a watershed, the more polluted the water bodies in that watershed will be. So that is one of the keys of really green infrastructure, is to reduce the amount of impervious surface and restore or retrofit back in some of these natural systems, so we can basically bring down that red and mimic this natural site hydrology or stormwater, and therefore we don't have to rely on the gray infrastructure so much. And that really is what green infrastructure is all about. You'll hear folks often use the terms low impact development, or LID, and green infrastructure synonymously, and for the most part they really are. There are some nuanced differences. Really, green infrastructure can be thought of as the US EPA's low impact development program. You can also think of low impact development more of a design and theory and idea, as opposed to green infrastructure as the actual implementation or the actual practices. I think green infrastructure also has been known to sort of take LID a little bit further, in that it also gets into capture and reuse of rainwater and stormwater back onto the site, or potentially within the building, where LID historically has not taken it to that direction. But they both really have the same central tenets and designs in mind, and they both really seek to reduce runoff volume on the site. They both seek to reduce peak runoff rates, discharge rates leaving the site. So the overall goal is to reduce stormwater discharges, whether it's the rate or the volume leaving the site. They both seek to either implement or preserve on-site systems of natural filtration or biofiltration. And the overall goals are pretty clear when these are your main objectives, and that is to reduce pollutant loading, to reduce off-site flooding, to protect or improve water quality, to protect or enhance wildlife habitat or biological diversity, and consequently, on the last checkpoint here, usually when we increase green space and green materials and vegetative materials, that also has a positive effect on aesthetics and land value. Folks more and more are always going to choose natural systems, not always, but almost always choose more natural systems in their landscape and their properties over rock and riprap and concrete and steel, and we're seeing evidence of that pretty readily around the country as well. Some studies here from compiled by North Carolina State University that are bearing this in mind, and this is really one of the areas where green infrastructure really starts to merge into green building. And just to touch on each one of these studies here, we found that, or in the compilation of studies that North Carolina State put together, they found that home sites using green infrastructure increased their value by about 6%. They also found that they could lower the cost of construction and installation, as well as get a higher resale value to the tune of about $9,000 on average per unit sale. We also know that if you can increase or reduce flooding or improve water quality in areas where it's a known floodplain, or water quality can be an issue, or where there's a high value water body like a lake or something like that. You can increase the value of the real estate by 5 to 15%. And then really getting into the heart of green building as well. But we know that implementing green infrastructure around or on a building, meaning also a green roof system, can have the effect to reduce energy use between 1/3 and half. And actually green building used the same figure as well as green infrastructure data does for this one, which is pretty unique. So generically speaking, what is green building? So the U.S. Green Building Council really has these 5 main tenets of what green building is, and this has been used to build the LEED program, Leadership in Energy and Environmental Design, and where Filtrexx relates to this system is not in all 5 of these pillars or with compost-based BMPs. We fit in directly to material use, site planning, and water management. We don't really get into indoor environmental quality as you might imagine, as well as energy as well. And that's not to say that couldn't be, the energy portion couldn't be incorporated in future iterations of the LEED program that we have yet to be seen. According to the USGBC in some of their reports, green buildings can have the ability to reduce energy by 24 to 50%, carbon dioxide emissions up to nearly 40%, water use by 40%, and reduction of solid waste by 70%. We know that buildings are one of the largest consumers and users of each one of these potential materials or outputs in terms of emissions. We actually have very similar values for green infrastructure and compost use. So these programs really fit hand in hand, and in reality cannot really intimately be separated as such. And you're going to see that as we move through the program. So what is LEED? LEED stands for Leadership in Energy and Environmental Design. It's been around for about 15 years now. It's the leading green building rating and certification program in the world, and it really seeks to place not only a guarantee but also a market value on high performance green buildings that both help to protect and restore the environment, as well as provide healthy environments for folks who live in the buildings or work in the buildings. If we were to look at, this number's a little bit dated at this point, but if we were to look at the footprint, overall footprint of LEED projects, there are currently about 30,000 projects that have registered through the LEED program. If we were to look at those that have actually been certified to date, it's a little over 8,500, and if we were to look at that in a square footage term for certified projects, it's approaching 1.5 billion square feet. If we were to break this up and look at the demand and the growth in this sector, you can see that the growth, and if anybody has been working in this area or been watching it closely over the years, you've noticed the massive growth that we've seen in green building and the LEED program. That's evidenced not only in their conferences, but in the companies who are getting involved, all the Fortune 500 companies that are getting involved, and the ordinances that we're seeing pop up all over the place in major cities as well. But if you were to break apart, you can see here in the table the projection from 2006 to 2010. Obviously this is a little dated, but we saw really massive growth in this area even during the construction downturn as well. So what is pushing the demand in this area? Well, as I mentioned in the last slide, we're seeing a very high level of government initiatives that are pushing green building and LEED. We're seeing green building ordinances pop up in a lot of the major cities that basically almost copy and paste, or at least closely mirror the LEED program, and have put into city ordinances for new buildings. We've also seen that new government buildings, whether they be in certain states or cities and also at the federal level, are required to meet a minimum level of LEED certification, and in some cases we're seeing that now needs to move beyond just the minimum level. It's now being required to be LEED Silver, which is the next level of certification up from just being certified. We're seeing a huge demand in the residential and in the education sector for green building and green construction. Families want to know that they're living in houses where they know where whether some of the materials are off-gassing or potentially creating health concerns. People want to work in buildings where they are that are going to make them happier and more productive. There's quite a few studies now that are showing that workers and employees in green buildings usually have fewer sick days and are more productive throughout the year as well. And we're also seeing educational institutions, whether they be K through 12 or university level, really like the idea and are commissioning green building design and construction, and in many cases LEED buildings, not only for educational purposes and demonstration purposes, but also for the health of youngsters as well, particularly in the K through 12 sector. And then also there's been a huge upshot in the design and improvement and availability of sustainable materials and products that are being used to build the green buildings. So this is actually an area where Filtrexx really fits squarely in this growth pattern, and that is we're using compost materials in just about everything that we do, which is locally sourced, recycled, biologically based, and so we fit squarely in that upward trajectory of new and available materials that are that LEED programs and green buildings are seeking out to build their projects. So there are various levels of certifications, which I've already alluded to, as well as various programs for LEED. So there's a homes program. There's actually various other types of green building programs related to residential construction in this area. Earthcraft House is one that you may be familiar with that is used quite a bit around the southern United States. There's one for neighborhood development, commercial interiors, just the core and shell of the building, for schools, for retail and healthcare. But the original one, and by and large the one that still gets used the most, is for new construction, or often referred to as NC. So whereas each one of these certification programs have nuanced differences, they're all fairly similar, and they're all sort of originally built off the new construction concept. So as I get into the LEED credit categories, they are specifically for new construction, and you'll see that. There are 4 levels of certification, the lowest level being just what we call LEED certified, moving up to silver, gold, and then the highest level is LEED platinum. And to attain each one of these, you just need to achieve a certain amount of, be awarded a certain number of LEED points or LEED credits in order to achieve one of these levels of certification. So let's talk about the compost portion, the compost BMPs, and then how Filtrexx fits directly into these programs. So with Filtrexx, we're using compost media for really every one of our applications, and we use 2 different types of media. One is what we call filtration media, which you see on your left here, and one is a growing media, which you see on your right. So one of the take-home messages that I want you to remember, and you'll notice here, is that neither one of these look like the type of compost that that most of us are used to seeing or using in our everyday lives, whether it's in a garden or buying a bag from your local garden center. These are both actually quite different. And the key difference is the particle size, and you're noticing that. You're thinking these look very coarse, both of them in nature, and that is by design. A lot of research has gone on to evaluate and develop the best possible particle size distribution for these applications. And the one on the left, specifically designed for filtration and biofiltration, is required to have a certain amount of water or hydraulic flow through, but we want to filter a variety of stormwater pollutants. The one on the right, we're really trying to mimic a forest floor, forest duff layer type system. So we're trying to absorb rainwater, but we're also trying to create surface roughness as well. So we have some coarse materials in there. And one of the chief goals also being that we want to promote and sustain plant growth. So this is a list of all the best management practices that we use in stormwater management. There's 24 different ones here. Every single one of these use compost either in whole or in part. Okay, and they use one of those two types of media that I just showed you on the previous slide. The ones on the left here are construction activity stormwater management applications, and the ones on the right are for post-construction or really low-impact development. But every single one of them use compost and can be used in a green infrastructure or green building context. So I wanted to give you a just kind of a visual here of what a lot of these look like, and these are what I consider really the loose applications. Okay, so these aren't the type that we're putting in a SOC system, which I'll talk about later, but these are usually used most for either slope stabilization or absorption of rainfall, and therefore reduction of runoff as well. So you see these used a lot around stormwater ponds. There's a green roof system in the bottom, as well as a rain garden and bioretention system as well on your right-hand side of the screen. Now we're using the coarse media. We're using the finer growing media in the previous applications. We're using the coarser filter media in the applications you see here. So all of these are using that filter media inside the Filtrexx filter SOC system. We're using that for perimeter control applications, storm inlet protection, check dam, slope interruption device you see in the bottom left-hand corner, sediment trap in the top left-hand corner, as well as biofiltration type systems where we can combine the type of media, both growing media and filter media, and add vegetation, and then we can filter not just sediment but also a variety of post-construction stormwater pollutants as well, such as nitrogen, phosphorus, hydrocarbons, and metals. And there's a third broad category, as I like to refer to them, and that is putting the growing media inside the SOC. And we'll do this when we want to have the SOCs be a permanent application and provide permanent stabilization, whether it's on a storm channel, bank, or some of these biofiltration type systems. We also use them in tidal creek scenarios and stream banks, as you see here in the photo panel. So one thing I want to do is I shared with you that first slide of what happens as we change our land use patterns from natural systems to the urban environment, and we looked at it on really a watershed scale. Now in reality, most of us don't work on a watershed scale. Most of us work on a site scale. scenario is now we have greatly increased the surface water runoff percent, or really volume, as well as the pollutant load in that, and then that washes down into the water body. Well, one of the nice things about compost applications is, from a hydrologic perspective, we can actually recreate these hydrologic values as quickly as we took them away. Now, don't misunderstand me. I'm not advocating for mass clearing and grading and simply putting down compost blankets. But because part of LEED and green infrastructure is to protect as much of the natural site as you can. In fact, LEED actually awards points or credits for that. But where you can't do that, because this is a land development scenario, we want to use as much of the natural materials and systems as we can, and compost represents a way to do that, to quickly get organic matter back into the system, absorb a lot of that rainfall, and begin to reintroduce a lot of the natural hydrologic cycle, like you see here, through evaporation and transpiration, surface water that is detained or infiltrated. And then also we know that water that infiltrates actually gets naturally filtered in that process, and actually the compost filter sock actually works in that same capacity but above ground, so we don't necessarily have to have the benefit of infiltration or detention within the soil or below the soil to get that natural filtration aspect. We can actually do that above ground if we put a compost filter sock in the flow path, where we know we're going to have some runoff, and during construction we know we're going to have more of it consequently. So I want to share with you some studies that sort of bear some of this out, and this will then have direct relation to some of the LEED credit categories I'm going to share with you here momentarily. So this is a study that was done at the University of Georgia, published in the Journal of Soil and Water Conservation. But we found that a compost blanket could absorb approximately 84% of a 4-inch rainstorm. So if you think about that for a minute, what this means is during 90 to 95% of your rain events that are a 1/4 inch, 1/2 inch, 1 inch, 1.5 inches, compost blanket is going to absorb all or most of that rainfall. And if you're absorbing all the rainfall, you don't have any runoff. You don't have any runoff, you don't have any transport of pollutants, whether it's erosion or post-construction stormwater pollutants. So this is actually low-impact development, or really green infrastructure at the source. Not only are we keeping the runoff on site or dealing with it on site, we're actually keeping the raindrop exactly where it falls. And because of this, we can actually not only reduce stormwater volume and pollutant loads, we can actually reduce not the potential pressure or even the size of our bioretention systems or our stormwater ponds. So, or help meet a LEED ordinance where we may have to have a certain volumetric reduction in discharge, and you're going to see how this relates to LEED here momentarily. Other studies that are bearing this out, there's a couple from the University of Georgia, one from University of Connecticut, and one from Iowa State University that are showing between nearly 50% and 90% reduction in stormwater runoff volume. Peak flow rate as well, we're seeing from some of the same studies between 36% and nearly 80% reduction in peak flow rate. We're also seeing through a variety of university studies, starting from the top here, this is Texas A&M, 2 from the University of Georgia, and 1 from the University from Iowa State University, that are showing that we can greatly reduce the pollutant load, or really the massive pollutants coming from a site that use compost blankets versus the way that we typically establish vegetation through seeding practices. So each one of these studies compared compost blankets to some sort of vegetation practice, and you see which one they compared it to in parentheses here on the left: seed and fertilizer, hydromulch, and seed and topsoil. And these percentages are the percentage of that pollutant that was reduced using compost compared to conventional vegetation establishment practice in each one of these studies. So just to kind of help clarify this a little bit, I'll use the first example here in Mukhtar et al. 2004. They found that a compost blanket compared to seed and fertilizer could reduce total nitrogen loading by 88%. So you'll see throughout of each one of these studies and pollutants, there's pretty consistent nature of the reduction in the pollutant load across a variety of these studies, and there's quite a few other studies that have been published that also bear this out as well. There's two reasons why this is occurring. Okay, the compost blankets are drastically reducing stormwater volume, and because they're doing that, they're also reducing pollutant load. They also supply nutrients in the organic form rather than mineral or inorganic form, and because of that, they're much less mobile in runoff conditions, and therefore actually typically more often will stay where they are as opposed to wind up being transported in the runoff and making their way into a storm drain or into a surface water body. This is the study that by the USDA research service published jointly in the JEQ as well as Stormwater Conservation. Valuable pollutants like we typically see in post-construction. I should iterate here that in construction activity stormwater, sediment obviously is usually the chief pollutant of concern, and the reason for only basically going after sediment and these applications is where is in high concentration, disturbance through the sediment. So you can or impervious surfaces, but we shouldn't have a lot of sediment. And so each one of these pollutants are in the free-floating or the soluble form. And what you're seeing here is the percent removal efficiencies of the compost filter sock or biofilter for each one of these. So looking at nitrogen species, total insoluble phosphorus, total coliform and E. coli bacteria. We looked at a range of metals, cadmium, chromium, nickel, lead, and zinc, as well as oil and diesel fuel. Wanted to share with you briefly a case study where we evaluated the use of the Filtrexx filter sock and biofiltration system in the field. So this is a project that we did with the city of Chattanooga. They were out of compliance for their MS4 stormwater permit, or municipal separate storm sewer system permit. You see in the picture to the left, this is a picture of a 5.5 acre parking lot where they store and service a lot of their city vehicles. In the picture on the right, you can make the outfall system there in the lower left-hand corner of the picture, and you can see a fence line in the upper portion of the photo. Well, that's their property line. So once the stormwater exits the other side of that fence, it really needs to meet certain stormwater quality criteria. Well, they were out of compliance back in February of 2007 for chemical oxygen demand, suspended solids, and oil and grease. And we partnered with them to help them get back in compliance. And you can see at the next stormwater sampling and analysis in June of that year, we got them back in compliance. I have data here through 2009, but we actually kept them in compliance through 2012, at which point they removed the system to put in something else that they wanted to use for demonstration and educational purposes. But throughout this period, we kept them in compliance. You can see the percent reduction for each one of the pollutants of concern that they were out of compliance with on the right-hand corner of the table, or the right side of the table. And they were so pleased with the way the system worked that they actually began to train other municipalities in Tennessee on how to use and implement this type of system for MS4 compliance. Some of you may be familiar with the Sustainable Site manual that we've published in partnership with Forrester Press or Forrester Media. It's a design manual for green infrastructure and low impact development. You can see a little quote here from Forrester Press at the bottom, who's the publisher. But what the key to this manual is that it has each one of these 24 different compost-based BMPs that I showed you previously, and it has very detailed specifications and design criteria for each one of them, from sediment control to bioretention and biofiltration type systems. So it gets into where to use it, how to design it, how to size it, how to maintain it, how to inspect it, what media to use, various advantages and disadvantages to using each one of the systems. But one of the key reasons I'm sharing this with you, not only because if you're a designer this will be very helpful to you in these applications, but within each one of these sections, let's see if I have a description here. This gives you here this bulleted list of each one of these BMP specifications and what it has inside as basically a mini chapter for each one. But under the advantages and disadvantages section, we've included an area of where that specific compost-based BMP fits into each individual LEED credit category. So if you are potentially using the Filtrexx sock for sediment control, you can look in that section and see which one of the specific LEED credit categories that you can apply that system to or that product in, and to help potentially lead to those credits listed. So as you are going through the webinar and you see the list of 24 different applications, you then begin to see you potentially have the ability to design a fully sustainable site using nearly exclusively these compost-based BMPs, from using it in rain garden and bioretention systems to green roof systems, bioswales, engineered soils, using it compost blanket to absorb rainwater and reduce stormwater, even including it within a green paver system to help establish and sustain vegetation within the green paver. One of the key reasons why folks are attracted to compost BMPs within the green building sector is because of the inherent sustainable components or advantages or attributes really of compost and using it in these applications. And I would say that even more so in LEED and green building programs than green infrastructure, because the LEED has actually been able to be a system that awards for selecting for yet. Initiative has done that and is doing that in general, and water materials. $4,000 composting facilities located or distributed across the United States. Because of this, we can potentially source compost just about anywhere, so this is automatically going to reduce our carbon footprint, as we're not transporting products or materials from overseas or even cross-country, because we can get it mostly locally. This also reduces our carbon footprint because we are preventing organic materials from going into the landfill when we create demand and market demand for these compost materials. So some of you may or may not know that organic materials going into our landfills are the leading source of methane generation in the United States. And methane is a greenhouse gas that is 18 to 25 times more concentrated in carbon than carbon dioxide is. So it's what we say about 20 CO2 equivalents per unit or per molecule. So just by choosing, you may be already doing a green building site or green infrastructure, but by choosing compost over some other type of material, you are already reducing your carbon footprint drastically by reducing greenhouse gas emissions. Obviously, there's not a lot of rocket science here. We're just following natural principles of using organic materials and organic matter, much like Mother Nature has been doing for many millions of years. And really, one of the reasons I think why green building practitioners and professionals really like using compost is it really helps them move from and this is one of the objectives of the LEED program, moving away from or really building upon not just being benign to the environment, but really being restorative in nature. So I think we've moved past the point, or at least in some of these programs, where it's not okay just to be neutral anymore. We really need to design and implement systems that are really restorative in nature. And also part of the main mission and objective with LEED is that these things need to be high performance, and there's certainly a lot of data that shows that the compost-based BMPs are high performance BMPs. So let's get into the specifically the LEED credits in each one of the categories here. So this is for new construction 3.0. This is each one of the sections that you'll see if you were to look in new construction: sustainable sites, water efficiency, materials and resources, innovation and design process, and regional priority credit are the ones specifically where compost-based BMPs can fit squarely into helping to achieve credit accrual. Now you'll see in black parentheses, in black text, how many total credits you can get in each one of those categories, but I've highlighted in red how many in total the compost-based BMPs can help you lead to. So a maximum of 17 here, and there is a potential to get more down with the last two, innovation and design and regional priority credit, meaning that if you do something that with a compost-based BMP or Filtrexx system that really hasn't been done yet, it's pretty unique and creative in the design process, you can potentially get another credit for that. Or if you specifically use it to target something of regional priority as deemed by one of the local regional U.S. Green Building Council chapters, you can also get an extra credit for that. For instance, in Atlanta, air quality, water conservation, transportation, stormwater are all kind of major issues for this area. So if you were to tackle some of those specifically and do a pretty good job in the design process at reducing the impact on those, you can potentially get more credit. So this is sustainable sites, where you can potentially, this is probably the credit category that most people think about when they think about using compost. I know when I consult with designers and green building professionals, this is where they think most readily of where organic materials and compost and Filtrexx products specifically fit in. And it does go beyond this, which we'll talk about here momentarily, but you can potentially get 6 credits here, as you'll see. The first one is in brownfield redevelopment. You can get a credit. Specifically for redeveloping the brownfield, but compost has been used for many, many years to help redevelop and stabilize pollutants and remediate pollutants in brownfields, and that's generally how it's used in that specific application. 5.1 site development: if you can protect or restore habitat, you can get a point or credit. If it's a previously developed site, if you can restore half of it, you can get a credit. compost has been used and is used widely for site restoration, whether it's land reclamation, ecological restoration projects. So it fits really squarely into that as well. The next two relate to stormwater design, the first one for quantity, the next one for quality. Excuse me. In reality, if you're doing the first one, you're probably getting the second one as well. As you probably, you've probably garnered that from the webinar as well. If you can reduce quantity, you're often improving water quality as well. But there's a few ways to get this, at least in 6.1, and that is if the site is less than 50% impervious, then you need to restore back to the natural hydrology or protect receiving stream channels. We've seen examples that I've showed you of how you can restore natural site hydrology as well as stabilize and protect stream banks and stream channels using the Filtrexx systems. If it's greater than 50% impervious, then you only need to decrease your stormwater volume and peak flow by 50%. So somewhat similar to restoring natural hydrology, but only bringing it down by 25%. You're going to do that very much the same way as you would restoring natural hydrology. It's just that your benchmark is a little bit different. 6.2 stormwater design. You need to reduce your suspended solids by 80%, either through capture or treating. From 90% of the annual rainfall for most of the country. That's about the first half to 1 inch of rainfall. So there's a variety of ways to do that. You can reduce your stormwater volume. You can use bioretention systems and biofiltration systems as well. And I talked a little bit about that and showed you some compost-based BMP examples of that. The next two relate to urban heat islands, or the heat island effect. The first one relates to the non-roof, and this gets directly into green infrastructure around the building. So if you can reduce or for the hardscapes that are designed and implemented around the building, if for half of them you can include compost and vegetation and show that they will be shaded, or 50% of the hardscapes will be shaded 5 years after implementation, you can get that point. So that's going to also potentially have an effect on energy as well. 7.2, heat island effect for the roof. This relates specifically to the percentage of the roof that either you're putting into a green roof system, half of it needs to be in a vegetated or a green roof system, or you can implement systems that reduce the really the color. So if you're designing for lighter color roofs that have a lower or higher value solar reflective index, which is selecting for something closer to white rather than dark, you can help get that as well. But related to what we do, we use compost as a component in the green roof systems, and that can help you get to that point. The next credit category is water efficiency. You can potentially get up to 6 credits by utilizing or implementing some sort of compost-based system. The first two relate to the landscape. So if you can reduce your irrigation requirements in midsummer usage and demand by 50%, you can get 2 points. If you can get rid of your irrigation altogether, you can increase that to 4 points. So there's a lot of ways to do that, from choosing the right materials, plant materials, native species, which have a much lower, typically have a much lower water irrigation demand, to increasing organic matter in your soils through the use of compost, through also capture and reuse of rainwater and stormwater, because this is based just on potable water use, not not water that you capture and reuse. The last one, innovative wastewater technology, is a little bit different, and that is you can get 2 points by either reducing the volume of wastewater discharge or by treating half of it before you discharge it. So reducing water, your wastewater can be done through waterless urinals, low flow toilets, use even a composting toilet like you see here in the diagram. You can treat it through various systems like constructed wetlands, which often use compost, living machines like you see here in the middle of your screen, and Filtrexx biofiltration products have been used in the past in a variety of these applications. Lastly, materials and resources, you can get 5 credits. The first 2 relate to recycled content, so all of these are based on the total cost of all of the building materials of the project, excluding mechanical, electrical, and plumbing materials. So what this means is if 10% of the total cost minus mechanical, electrical, and plumbing are of recycled content, you can get a point. If you can increase that to 20%, you can get a second point. So we know that compost is 100% recycled, and that can help you achieve the goal for whether it's 4.1 or 4.2 categories. The next 2 sections relate to regional materials, and again based on the total cost of the building materials, again excluding mechanical, electrical, and plumbing. So the products or the materials need to be sourced and manufactured all within 500 miles of the building project. So that means the feedstocks, the source material, and the manufacturing, all of that needs to be within 500 miles. Well, because compost is almost always locally generated, it's actually usually too heavy and bulky to travel to send more than 100 to 200 miles. In fact, it's almost always used within probably 50 miles of where it's generated and manufactured or blended. So it almost always fits into this credit category, and if it can account for a significant portion of the cost of materials, you can get 1 to 2 points. And then the last one, rapidly renewable materials, again calculated the same way, but only 2.5% of the total cost of the building materials if the feedstocks or source materials can be generated in less than 9 years' time. So a lot of the materials that are being used to make compost are either recycled or plant materials that generate in much less time period than that, and if that is the case of the particular compost, then it can help lead to that credit as well. I wanted to wrap up here, and I know we're close to the end of the hour, but I wanted to share a case study with you, which I mentioned that I would at the beginning of the webinar. This is a LEED Platinum project. It was actually one of the first LEED Platinum projects to be completed in the state of Georgia in 2009, and this is the South Face Energy Institute when they designed and built their new Eco Office addition onto their existing building. You see a picture of it here in the upper right-hand corner. South Face Energy Institute is a green building nonprofit education, training, and demonstration center that's been around for about 35 years now, and they're probably the largest green building nonprofit and educational center, definitely in the Southeast and probably the Southern United States as well. A lot of folks come through this, come through South Face for education and training programs. So what you see here, there's a lot of really cool green building stuff going on with this site, but we're here to talk about compost and green infrastructure practices specifically. So we won't talk about what's going on inside the building or anything like that. We'll talk about what's going on top and around. So what you see here is they've used almost exclusively compost-based BMPs in their green infrastructure green building program. So from the green roof, which you see people walking around and enjoying in the picture on the top, and you see a close-up here on the left-hand portion of the screen, to using compost in their bioswale system, to using compost for erosion control and as a stormwater blanket around the perimeter area of the site, both for soil stabilization and for reduction of stormwater. We've used compost socks to build up the walls of the bioswale as well as the bioretention system to help reduce the footprint, as you can see here. We are in an ultra-urban type environment, so land area is at a total premium. Then we've also used compost blended bioretention media in the bioretention system. So what stormwater runoff we do have is directed into the bioretention system, gets naturally filtered through the compost-based media, and is captured down below in a cistern and then reused back into the landscape, and in some cases back into the building as well for non-potable water uses. So one of the nice instances about this project is not only is it LEED Platinum, but they've used almost exclusively compost-based BMPs. This is a zero discharge site in the middle of an ultra-urban type environment, meaning they are capturing and reusing 100% of the rainfall and stormwater that is either falls or is generated on this site. So because of that, they have never had a stormwater discharge in 5 years from this site, which is really remarkable. And we've had pretty big storm events. Because they're capturing the water, they're also reducing their water. You see a lot of vegetation in the middle of an ultra-urban environment, and probably a nice place to sit down and have your lunch. So with that, I've used up the better part of an hour, but I think we do have a little bit of time for some question and answer, and I appreciate your time.
Great presentation as always, Britt. We do have some questions, so let's see. We've got one from Robert. I apologize for not addressing this earlier to clarify as Britt went through the presentation. But Britt, when you were talking about the compost blanket, were you describing an engineered product or a generic term for loose compost spread out over an area earlier in the presentation when you were talking about the stats on absorption and so forth?
Yeah, good question. I did move through it pretty fast. The loose compost blanket is basically 1.5 to 2 inch thick layer of surface applied compost. It is not engineered, but it does meet a certain quality and characteristic spec for the type of compost used. So you can't use really just any type of compost or even high quality compost. It has to meet certain specification parameters to function that way. One of the key things being the particle size distribution of the compost itself.
And that should also answer your question, Aaron. That was a 1.5 inch blanket. They've asked where you mentioned the excuse me, I'm reading through trying to prioritize in interest of people's time. Are there any filter socks made of biodegradable materials?
Yeah, excellent question. Well, to begin with, all of the Filtrexx filter socks are 95%. around the building envelope and the rest of the site. Obviously, there's a short time period or temporary time period before the foundation goes in where you want to have some of that, but I think you're going to remove that, you know, as the building goes in, at least the footprint of the building or the envelope.
Thank you. And lastly, Michael asked, why will reusing reduce the carbon footprint if the compost will degrade in the soil where it's used, just like it will in the landfill?
Oh,
I think
great question.
we're talking about versus hauling it off-site. Michael, I'm going to unmute you to clarify. And Michael, I apologize. I've been getting a couple of pop-ups from GoToWebinar that there were some technical difficulties with the audio recording. Perhaps it's related. So I apologize, but Britt, maybe you can address that based on what we've read here.
Sure. So if an organic material goes into a landfill, it slowly will, but it becomes, that process becomes anaerobic because there's not really very little air or oxygen, and that's by design within a landfill system. So the gas that it creates, because of the type of bacteria that are there, creates methane gas. Well, in the natural,
Michael was not.
In the natural composting process, that does not occur because it's an aerobic process, and methane is not generated during aerobic processes. So, during the manufacture of the compost, you don't generate methane. And then also, after you have made the compost and it gets put out on the landscape, it does break down quite slowly, but no methane is generated when you're doing that.
Okay, there was one more question that I addressed in the background, but I think that it's worth mentioning for the rest of the audience. Someone asked, how are the products manufactured locally? Do you provide a specification and or certification for a local supplier? Britt, maybe you can address that for the whole audience.
Yeah, it's a great question too. Filtrexx has certified manufacturers that we partner with or we certify to manufacture and generate the media that we're talking about. We do have a specification that is part of the partnership that they must comply with as well, and we also do regular third-party testing of their media at a third-party lab to make sure that it does comply with the specification as well. So if you probably to really to ensure you're getting the right material or the right media and to reduce any potential risk on a site, it's important not only to have the spec, make sure the spec is being followed, and really to certify that who's ever supplying the material is in fact complying with that.
Thank you. That's all of our questions, Britt. I want to thank you very much for presenting today. You've done a great job as always. And want to remind the audience that we have an August 6th webinar on Filtrexx Living Walls. And if you missed it at the beginning, I mentioned that Filtrexx has joined forces with the Living Wall Company. And now as one company, we offer a full suite of living walls with varying strengths and slopes and planting flexibility. So you'll want to tune into that webinar to get an overview of the full product line we now offer, and then we'll dive deep into one or two of the systems. And then on August 13th, we have the EnviroSox webinar. So you can visit our website at filtrexx.com to register for either one of those or any of the other upcoming webinars. I will be sending certificates of attendance for those of you who attended the majority of today's broadcast, so you can use those to earn your PDH credit. And if you have any further questions, Britt's contact is there on the screen, and we are always available to you. Thanks again, Britt, for your presentation today, and this concludes our broadcast.
Yeah. Thank you, Ann, and thanks everybody for tuning in.